Hi, I'm Dr. Simon Harding from Machine Intelligence. I'm an engineer, software developer and scientist who's worked across academia and industry. I set up my own company to take some of what I've learned out of the lab and put it into the real world. And today I'm here to talk about Machine Intelligence's work with the BAE Visual Inspection Challenge. So what's the problem? At BAE, as in all manufacturing, products must be checked for defects. Quality and safety, of course, prime drivers for this, but reducing waste also has clear financial and environmental benefits. Visual inspection is one of the most common and obvious checks to make, and for some products or components, this can be easily automated. Simple pattern matching might be all that you need. All toasters should look the same. For other components, the inspection may be more complicated or less easily defined. Maybe the piece is organic, checking fruit for disease, or maybe the piece is handcrafted, hand-finished, an artisan piece. I don't just mean something knocked up in a shed for a craft fair, but this is something common, surprisingly common in low volume, high value manufacturing. And here humans are typically used. But humans lose focus, get tired, make mistakes, and are expensive. So what's the typical route? Cameras coupled with machine learning can be used to alleviate or at least help alleviate some of these problems. And lots of solutions exist. And people often jump straight towards neural network-based systems. However, these are black boxes and a complicated setup and often require many hundreds, if not thousands, of training images. And also, how does anyone actually know how they work in order to build confidence in their deployment? So there are alternatives. Machine Intelligence has been developing a technology that works in a completely different way. Using bio-inspired algorithms, it evolves computer programs. And these programs can be debugged, inspected, read, and understood. And because these programs can include domain knowledge, the solutions can be discovered with minimal training examples. MI's solution bridges the gap between humans writing software and machine learning. What once could have been engineered by a person can now be discovered by a machine. As part of this prototype, we've developed an easy-to-use user interface that takes the user end-to-end through the process, labeling training data, configuring the AI, teaching it, and also viewing the results. In this challenge, working with BAE, we have successfully used our toolkit to detect defects in X-ray images of welds. For finding these defects, X literally marks the spot. So we are developing and improving some fundamental technology and solving important problems in many areas. In the MVP stage, we would like to apply this system to other inspection challenges at BAE. MRI, ultrasound, and regular camera feeds can all be used, expanding our opportunities. At Machine Intelligence, we have developed a novel solution, which means we can move into novel domains, and we really can make intelligent machines. Thank you for your time and consideration.